You're listening to the Animal Free Labcast, the podcast that puts humans, not animals, at the heart of medical research. Hello everyone, welcome to the Animal Free Labcast. I am back today with Dr Gemma Davies. Hiya Gemma, how are you?
Hi Carla, I'm good thanks. How are you doing?
I'm great, thank you. Tell us what we've got in today's episode.
So today we're going to be joined by Dr Sam Aspinall from the University of Hertfordshire, who is working on developing an animal-free alternative to gelatin.
Gelatin?
Yeah.
I'm thinking trifle.
Yep, not quite. This is more of a sciencey version. But yeah, he'll tell us all about it later.
Science is good, trifle is better. Okay, well before we get going with that, tell us about the last episode's poll question.
Yeah, so if you remember, the question was, does knowing that animal tests often fail to predict human reactions make you stop and think before taking a medicine? And we had, the answers were 88% of people said yes, and 11%, or almost 12% of people said no. So, yeah, I think it's something that does bother some people more than others. We had some interesting comments as well on social media. Francesca on Facebook says, after taking chemotherapy, I started to donate to Animal Free Research UK as I knew those drugs had been tested on animals.
Oh, bless you, Francesca. Thank you.
Yeah. Hope you're doing well.
Yeah.
But Emma on Facebook said, if only we could choose cruelty-free, non-animal tested medicines, but it has all been tested on animals. We need to change this because it's completely unnecessary. And then we had some comments from Jan and Caroline saying they won't take anything that has been tested on animals. Emmy on Instagram says, I always want a diagnosis first so I can decide whether to take a medication. And I always check to see if there's an alternative. My doctor knows this already. Question a medication, whether there is another therapy available. Don on Instagram says, if I could choose untested medicine and treatments, I would. I think we should have the choice, and then it would be more proof that the public want animal-free research. So
it's a really interesting comments there. I guess it's worth saying that, you know, as it stands, all medicines have been tested on animals, and we would never say don't take medicines. But it's interesting to understand that there are issues with the safety and effectiveness of medicines because they're animal tested. And we really do need to be transitioning to human-specific medicine so that we can counteract those.
Yeah, so what have you been thinking about this week, Carla?
So it's September, which means that government is now back from its recess over the summer holidays. But of course, we haven't been sitting around idly twiddling our thumbs. Our team's been really busy meeting lots of MPs virtually to try and keep the pressure up ahead of publication of the government's strategy on phasing out animal testing, which we've been promised will be published later this year. We don't know when yet, but later this year. We've secured lots of in-person meetings, which are sort of all taking place now that Parliament is back. So thank you so much to our supporters who contacted their MPs to ask for meetings, because that really has helped. And we now have an absolutely staggering 127 parliamentarians supporting Herbie's law, which is incredible.
Yeah.
I can't get over that. There's 650 MPs who sit in the House of Commons, and that 127, yes, it does include some people from the House of Lords, but to have basically about a sixth of MPs now support our, pretty specialised subject is really important, and just shows kind of the support that there is out there from the public and from MPs and parliamentarians growing for this. So people are seeing that this is a really important issue.
Yeah, absolutely. We're really grateful to the supporters for getting in touch with their MPs, because that's how that has happened.
Yeah,
so
it's
that's
really
fantastic.
Made a difference. Yeah. So now that Parliament is back, we've got lots of meetings lined up with politicians. We're pushing for MPs and peers to table written parliamentary questions. We've already got some that have been asked by John MacDonald and Lord Clement Jones, which is amazing. They've only been back for a week. And we're now looking forward to the party conference season. So we'll be at the Liberal Democrat Party conference and Labour and Conservative Party conferences. First one is the Lib Dem one in Bournemouth. If you happen to be there, we'll be at stand 37. So do pop by and say hello to the team. We're going to have our giant Herbie. It's a life-size cardboard cutout of Herbie. So
bigger than life size, I think.
Yeah, bigger than life size. Yeah, much bigger than me anyway. And another brilliant thing that happened in the last couple of weeks is that Deborah Meaden, who you might know from Dragon's Den, and our photo shoot earlier in the year, she wrote a piece that was published in the Daily Mirror. A really fantastic piece. She said in it she wouldn't tolerate a 92% failure rate in any of her businesses. So why should we settle for that for something as important as our health? I couldn't agree more. If you'd like to hear more about Deborah, and listen to Deborah and what she thinks about this issue, then you can listen to the podcast interview that we did with her on episode 36. She's so passionate about this issue. So thank you, Deborah, for helping to raise the profile of the issue and get it in front of more people.
It's fantastic to have this support.
So that was a whistle-stop tour of all the things I've been thinking about. But
yeah, been busy.
Gemma, last time you answered some of our listeners' questions, and of course we didn't manage to get through them all. So we promised to come back to them. So we thought we could answer one now. So if you don't mind, Jess.
Yeah, of course.
Jess wanted to know, why are so many different types of animals used in research?
Well, that's a really good question. And lots of people might be surprised to know just how many different types of animals are used in research. When you think of research, you think of mice and rats, or the more controversial ones like dogs or monkeys. But you might not realise that lots of other types of animals are used in research as well. This includes things like frogs, chickens, ferrets, sheep, goats, squirrels, snakes, loads of different...
Squirrels.
Yeah, squirrels.
Yeah. That's dreadful, isn't it?
I know. Lots of different types of birds, things like quail, geese, robins, turkeys, blackbirds. Yeah, I know.
Yeah, sorry, I know I'm just repeating names of animals, but...
No, I know. It is really surprising.
It's shocking.
Yeah. There's also loads of different types of fish. It's usually zebrafish, but others like salmon, carp, trout, eels. Basically, if you can name it, there's a good chance that it has been used in some type of research, whether that's in the lab or different types of research. But the simple answer as to why all these different animals are used is because there isn't one animal that is similar enough to humans that can recreate all the aspects of a human disease.
Oh, so the answer clearly is let's just test on loads and loads of different types of animals then, and that'll get us closer to humans.
See what happens. Yeah. Some might be able to develop similar symptoms or disease that has some of the same disease pathways and the pathology. But every experiment done using an animal has some sort of key problem that means it can't tell us exactly what is happening in humans.
Because it's not been done on humans?
Because it's not a human. Yeah. So that long list of animals that I've just reeled off has come from the Home Office statistics. So we know that those animals have been used in British labs for various reasons, but we don't get a lot of detail on exactly what they're used for or why that particular type of animal has been chosen. The closest we can get is that the stats are broken down into sort of disease areas. So it does tell us a bit about what animals are generally used in which area, but it is clear that almost every single area has mice, which has the highest number of animals used by far. So when you get into the argument about, why are animals used in research at all? One point that is always made is that we share a large percentage of our DNA with animals. And while that is estimated to be, around 90% that's shared between humans and mice and other animals, it might be higher in monkeys, we also do share a high percentage with other things like bananas. So these figures can really vary depending on which type of comparison you're making. So it's not quite as clear cut as that. And there is some really important differences in how these shared genes are regulated. And those differences are exactly what makes a human being so different from a mouse, even though we share the genes. And that, of course, has a big impact. And it's in the same way that every cell in your body has the exact same DNA, but it's the regulation of those genes that tells that cell whether to become a brain cell or a muscle cell or a skin cell. So it's really important.
Yeah.
But it's worth pointing out as well that there's some really important anatomical differences between humans and animals as well. So, for example, a human lung has 5 lobes. So that's, it's sections of the lung.
Yeah.
And we have 3 on the right side and 2 on the left.
Really?
While a mouse, it's a bit weird to think about, yeah. While a mouse has 5 lobes on the right side and only 1 on the left. And obviously that can make a massive difference because according to the government stats, mice are the most commonly used animal by far to study the human respiratory system. So we're using an animal that has a completely different anatomy to try and understand ours.
I'm making a confused face now, everyone. This is confusing.
Very confused.
Yeah,
it is. It's not even just the live animals that we have to think about as well, because animal-derived products are also used really widely in experiments. Things like we've talked about fetal calf serum, animal-derived antibodies, and lots of other things that are used to help cells grow and in different parts of experiments. But these animal-derived products can add in a lot of variability into your experiment, and it can affect your results. So if you say you were trying to grow human cells and you were using a media supplemented with fetal calf serum that's come from a cow, you might then use trypsin that has come from a pig as an enzyme that detaches the cells from a plastic dish. You might then stain them using an antibody that's come from, say, a mouse. And then, suddenly, before you know it, you've used all these different animal products. And what is that actually going to do to your results? What signals are these products giving to the cells? Are they causing them to behave differently? You don't know. So it really does make sense that replacing those kind of products with either a human or a synthetic alternative should be a priority in research, so that you can know with as much confidence as possible that the results you are getting are truly related to what's happening in a human.
So you've got, on that side of things, you've got the science just isn't good enough because of the animals and the variability and the differences between animals and as opposed to humans. And then you've got all of the harm and the suffering caused to those animals, either the live animals that are being used and the animals who are also suffering to make these hidden animal-derived biomaterials that are used so widely.
Exactly. And I think we've talked about this before. The animals that are used to get these products, the numbers aren't recorded anywhere. We don't have the statistics of how many animals are involved in making antibodies and everything like that. So the hidden cost to animals is so huge, but it also is not good science.
Well, that brings us really nicely onto today's guest, Dr Sam Aspinall, who's developing an animal-free alternative to gelatin, which, who knew, that is yet another animal product widely used in research that can have effects on your experimental results. I thought gelatin was all about jelly, which, that's why I want to talk about trifle today.
I mean, that's how most people will be familiar with it, but it is also really widely used throughout research and the healthcare industries as well.
So one of the things that we talk about often is the number of animals who are used in biomaterials. And this includes pigs and cows who are used for gelatin, which is what Dr Sam Aspinall has been working to replace in his laboratory at the University of Hertfordshire. So, gelatine. Who knew that was used in laboratories? Things just get weirder and weirder.
It's surprisingly really common as well. That's the sad fact of it as well. So because it's quite natural as well, obviously it's derived from collagen, it's from animal skin, animal bones, other things like that as well. It means it's quite good with cells. Cells really like to adhere to it. So we can use it in vaccines, biologicals, use it in drug delivery as well. It's easy to use, it's readily available, and it's cheap, which is a perfect storm for something that we use in labs, which ideally we really shouldn't be using, but it's out there and quite common.
How widely would you say it is used throughout kind of research and healthcare?
Oh, in the vast majority of labs at this point, because it's so cheap, so readily available as well, and because it is quite good with cells. Cells really like to adhere to it. You can use it for propagation, other things like that as well. It's used in quite a lot of labs around the world at this point. I mean, about 65 million animals every single year are used in the production of gelatin, and although it is a byproduct from the production of meat and other things like that as well, it still equates to about 500,000, 600,000 tons of gelatin being produced every single year at this point to be used for other than just foods, for being used in cosmetics, healthcare industry for research and things like that.
So, Sam, without getting too technical, because I am not a scientist, and I imagine many of our supporters aren't either. When you say that it adheres to the cells, so it sticks to the cells, like, why do you want gelatine to stick to cells?
So it's quite a natural environment for them to stay in as well. They're quite happy to stay there. They're quite happy to propagate, to grow, and to breed as well. So you can keep them in one place while you're doing your experiments as well. So you can then start adding food, start adding other compounds to it as well, and just making quite a nice environment for the cells to be in general as well.
So you're sort of making them stay put within your petri dish or your well plate or wherever it is that you're growing them.
Yeah, exactly.
Okay, thank you. That makes sense.
So if it is so widely used and, like you say, the cells do like it, what are the scientific problems that you can get by using gelatin?
So anything that's naturally derived will obviously contain lots of impurities inside of it as well. If we think about us as humans, we're not exactly the cleanest animals on the entire planet as well. So you're going to have endotoxins, you're going to have enzymes, you're going to have other things inside of it, which you're going to have to purify, you're going to have to extract and remove and try and make this gelatin as pure as possible. Problem with that is it's quite hard, it's quite expensive to do as well, and if there are any contaminants it will ruin your samples as well. You'll then have interactions for your cells, give you false positives or false negatives at that point as well.
Would you know?
For mechanical properties.
Sorry, Sam, to interrupt you. Would you know if that had happened?
You'll be able to tell after a while, yes.
Because you're getting weird results.
So you would be able to test beforehand, obviously, to see whether it is pure as well. But if you get weird results, you're expecting all these cells to be happy and all of a sudden they start dying, or if there's some sort of like enzyme that's interacting with them or just some problem that you generally would see, then you'd kind of sit there and go, this doesn't look quite right here. Is it something that I've done? Is it the actual gelatin itself? Is it something else along those lines as well that's causing the problems?
So it can slow you down.
Yeah, slow you down. It can obviously, you may think, this has worked. All these cells have died inside here as well. I've created something that's absolutely fantastic. It kind of reminds me of the example of dogs and chocolate as well with humans. Like if we looked at dogs eating chocolate, obviously they can't consume it. And we will all turn around and go, this is toxic. Why would we ever use this? Why would humans want to consume it? If we have these problems that happen in these petri dishes and we suddenly turn around and go, was it the compound I was testing? That could be a compound that could treat some horrific disease that we desperately need being wasted at this point now because we thought, obviously something else has happened there.
When you've pushed a button there saying that there's a potential reality where we wouldn't be able to eat chocolate, I can't imagine that. That's a terrible world.
Devastating.
It's not one I want to live in.
Use it. Always use it as an example as well, because it's one of those things that if we rely solely on animal-derived products and animal tested, we won't really get the accurate results that we need to mimic humans as well at this point.
Yeah, absolutely. So why is this an important issue to you, Sam? How did you get into this area of research?
So I've always been a massive fan of animals in general. My dream growing up was to actually be a cat dad, which sounds really cheesy and funny in itself as well. It doesn't really pay the bills, ideally, as well. I do have 3 cats at the moment. But my thinking is, why should we make these animals suffer just so we get something out at the end of it as well? Why should research then focus on, we obviously have to test this on animals to make sure it's valid at this point? Surely we've come to this age now where we can kind of make alternatives as well. We can actually develop these things as well. And I've just always wanted to try and make something with these polymers in general as well. Most of my PhD was looking at polymer science as well, so this is just like an expansion from it. And this research area in general, I used to work with a colleague who's now moved to UCL called Mike Cook, and he looks at thermoresponsive polymers and thermogels and things like that. And it was just a conversation we had when we were talking about one of our PhD students, Linda, and she's making gels and similar things to this. We thought to ourselves, well, is there any way that we can build off her work, kind of make things like these different gels that are able to actually replace gelatin, actually replace all these different cell cultures, can be used in all these tests that eliminate the need for animal-derived products in the first place as well. And then this research area and this project that we're going to talk about was then born from that.
Stick.
Yeah, can't wait to hear all about it, yeah. But is there a human equivalent of gelatin that could be used in research, or would it have to be a synthetic version?
So as morbid as it sounds, humans can be used to produce gelatin because obviously we're made from collagen, we're made from bones and hair as well, and ethically, no. And secondly, I don't think that's ever going to get approval anywhere as well. So the human equivalent of gelatin would just be human-related gelatin, but there are natural alternatives out there as well, and it's like agar-agar, there's xanthan gum, there's carrageenan. But the problem with them is, although they are natural alternatives, they don't really give us exact properties of gelatin as well.
I wanted to ask you about that because obviously, like from a food perspective, you can get vegan jelly, right? You can make vegan trifle. Like, I realised that your application, that your use of it is different. But yeah, so what is the difference? Why can't you just use, vegan jelly?
So they either have problems with the actual structure, the actual texture as well. They can't quite mimic it. Either cells just don't want to interact with it in the same way of gelatin as well. Sadly, just like some vegan products are compared to the actual products, well, like vegan cheese, it's not quite there. You can always kind of tell there's a little bit different as well. Although, to be fair, I do like vegan/vegetarian chicken and meat, but that's gone off subject here as well, isn't it? But they're not quite there.
Not quite there.
They're good alternatives,
Yeah,
but
they're
they're
not
not exactly what you want it to be. So a synthetic option that is either equivalent or better, in the case that we're hoping to get out of this as well, will then provide a much more ideal route than using these alternatives.
So tell us about your alternative then. What is it? What is it? How did you make it? Oh, I'm sorry, my dogs have decided to pipe up. I don't know if you can hear them, but
that's okay. I'm generally surprised my cats haven't decided to try and come and see what's going on at the moment as well. So the research project was called Thermopigs as well. So it's thermoresponsive polymers imitating gelatin. It's surprisingly it took us longer to come up with a name for the project and actually did come up with the project itself as well.
It's a good name.
Essentially
It's a good name. It's catchy.
Yeah. Quite proud of it as well, which is a bit shameful at the same time. But so essentially we decided that there's these polymers, so they're called UCST polymers and upper crystal
What's a polymer? Sorry, Sam. I meant to ask you that earlier. Yeah.
That's okay. A polymer is basically a repeating unit of the same molecule as well. So you have a monomer, which would be the single unit. So if we think about styrene in this case, you then polymerize it, make it into these long chains. You've got polystyrene at the end of it. So it has much different properties than just the single compound on its own, because there's a lot more of them as well. So one example of that would just be urethane as well, which is a nice simple liquid as well, but then you get polyurethane, which then turns into a plastic bag. You keep adding more monomers to it to make a longer polymer, and you've suddenly got plastic bottles. So you change the properties depending on how long the chains are, the bonding, the actual crossing over the intermoleculars. Lots of complicated things, but essentially just think of it as a repeating unit of the same thing over and over and over again.
And that changes the properties of it as you do that. Yeah, that makes sense to me. Thank you.
So these UCST polymers, they have upper critical solution temperatures. That essentially means that higher temperatures are a liquid, and you cool them down and they turn into a solid. So at room temperature, it would be a nice solid gel, just like jelly. You heat it up, it turns into a liquid that allows you to cast it into these different shapes. You cool it down and it turns back into a solid at that point as well. So essentially, it's a polymer that behaves the same way that gelatin would behave in this case. Solid at room temperature or body temperature, heated up, it turns into a liquid as well. So that way you can get all the characteristics of it without it obviously being derived from an animal.
Yeah, it's so interesting. So obviously this has been the project that you've been working on with us. But what are your kind of future plans for this? Are you hoping to, I don't know, commercially sort of sell this to other labs, that kind of thing? Or
that would be the dream at the end of the day, but
yeah.
obviously not in it for the profit as well. I became a scientist, which, as we all know, isn't for profit, is it, at the end of the day? But it's actually just create a system that we're able to move away from using gelatin as well, use something that's better. We want something that's more accurate. At the end of the day, something that actually represents what it would be like if it was actually being used on humans, as opposed to saying, well, this is a good approximation of what it could be like as well. But issues, I like to try and move towards being able to bioprint it, turn it into some sort of like 3D printing things. You can actually then set it up. I'm naturally quite a lazy person, so any way of automating it somewhere that you can actually set it up and make these cultures for you as well is ideal as well. And hopefully try and turn this into some PhD studentships as well, so we can expand on that work, have other people then do research as well, expand out as well, because obviously when they leave, they then take their skills with them and hopefully expand this area of research, which would be quite nice.
Have you got to the stage, Sam, where you've perfected the Thermopigs, the sort of synthetic gelatine, and you're now able to use it in your wider work or in the lab?
It's almost there. We do have quite a few of these polymers as well that are being tested at the moment. So we're just trying to fine tune their properties at the moment as well, try and find out which ones are the most ideal to mimic something like room temperature, body temperature, other different combinations. And then we're going to take them forward to cell work to see if they're compatible. And then once that's complete, then expand upon that as well and try and then start rolling out onto other things.
Brilliant. That's really exciting.
Yeah. It really is. And it can make so much difference because, like you say, it's so widely used in pretty much every single lab. So, if people started replacing that with the synthetic version, that could really improve research, but also save so many animals as well. It's fantastic.
No, I do hope it works. I do hope it does get the expansion and the recognition it needs at this point as well.
Well, thank you so much, Sam. That was really interesting to hear about your work. Do you think this will sort of be something that we see in labs, over the next few years, hopefully?
Yeah, hopefully in the next few years, if we continue to keep doing research on it and continue to keep, putting all our efforts into it, then hopefully in the next few years, we should see a slightly wider rollout than just the pilot study that it's on at the moment.
Yeah, brilliant. That would be fantastic. Yeah, we'll keep our fingers crossed, and please do keep us updated on how you get. But before we let you go, Sam, I have to ask you the most important question of all. You mentioned you've got 3 cats. What are their names?
I've got one called Sapphire, one called Momo, and a little baby called Dusty at the moment.
Brilliant
little
names.
Sweeties.
Yeah.
Well, thank you so much for joining us, Sam. It's been fantastic to hear about your work. Please do keep us updated, and we look forward to hearing how you get on.
And thank you for having me. It's been a real pleasure to be here. Thanks.
Well, we'll be back in a fortnight with all the latest from the heart of animal-free research. But before we go, Gemma, tell us this week's poll question.
Yeah, so it's, did you know that even though there are animal-free alternatives, gelatin and other meat industry byproducts are still widely used in medical research? Yes or no? So you can vote on LinkedIn, Facebook, Instagram or X, and we'll discuss the results in the next episode. But if you'd like to tell us your thoughts about anything in the episode or send us another science question for us to answer in a later episode, then please do drop us an email at hello@animalfreeresearchuk.org.
Thank you. And just repeat the poll question one more time.
Yep, it's, did you know that even though there are animal-free alternatives, gelatin and other meat industry byproducts are still widely used in medical research? Yes or no?
Thank you so much, Gemma. Thank you to Sam for joining us, and thank you all at home for listening. We'll see you next time.
Yeah, see you soon. Bye.
You've been listening to the Animal Free Labcast, the podcast that puts humans, not animals, at the heart of medical research. If you want to find out about more ways to move to a world of animal-free research, then head to our website, animalfreeresearchuk.org. And if you'd like to send us an audio message about the poll or anything else you've heard in the podcast, then leave us a voicemail on 0208 054 9695. That's 0208 054 9695. Thank you for listening.